Okay, right, so we're looking at being able to state the gradient of a straight line and also how to find the gradient from the function. Okay, so two things to look at. Now we've already done it, so it's just recapping really. We talked about it last time. So what we'll do is we'll move on here to the explanation. So here is a line. So this line would represent a function. Okay, so y equals something. So can you give me an example of a potential function?
Wait, by function?
Like y equals, that would give you a straight line.
Like 5x.
So y equals 5x, yeah, that would give you a straight line. Anything else? Y equals...
What do you mean straight line?
Like a straight line.
But how do we know?
Do you remember last lesson we plotted points?
Yes.
You got that in front of you and it ended up being a straight line. So that one was y equals 3x minus 4. And do you remember we talked and said, well, this number meant something and so did this one.
Yeah.
Yeah, we did that last time with that diagram in your book. So we're just recapping this really. So what we want to do, you see, is we want to make sure that you can work out the gradient. Now the gradient of the line, another way of saying gradient would be how steep the line is. So steepness.
Steepness, yeah.
Okay.
Isn't that when you count the...
By the way, I can print this page out for you afterwards, so we won't worry about writing it down. Stick it in. So this is the steepness. Alright. Now here's what we want to be able to do is we need to be able to work out the gradient from the line, because here look with the
I can see
the equation of the line is y equals mx plus c. Now we've already worked out that this number here, the one in front of the x, which is the m, links to the gradient, yeah? So if we can find the gradient, we can find that number. So for this one, yeah, Millie?
You just have to count like where's with the y is that's 4. So
actually, you know, this one, the diagram in front of you is rubbish. Because look where they put the point.
Yeah,
so that's not 4 at all. So we've picked one point here, okay, but I can't read what it is. Alright? This is a point I know. What point is that? Its coordinates are 0 and 3, I think, if I'm counting squares.
Yeah.
Now what I've got to do is I've then got to find another one where it's easy to read the coordinate. Alright? So what's the problem with the line that they've drawn?
It's not accurate.
Well, it is accurate.
Well, it is, but it doesn't...
But for us, it doesn't give us the chance to do what?
Find the gradient.
Find the gradient. Because we can't read from that line. Nice.
Well, they should do it from 3.
Well,
yeah, you can find the gradient.
Yeah, we could start from 3, but where's the next point? Because even that one there is not right on. So actually, they have not given us a second point. Anywhere on that line, there's nowhere where it actually crosses it across, where I know the coordinates. So it's actually a really rubbish one. But I think what they've done is they've just said, well, that to work out the gradient, we've got to do rise, okay? So that's the rise divided by, they call it step, but actually you might see it in other terms. So gradient would also be what we call rise divided by run. Rise over run, people remember. So actually step could be called run. There's another way. So what we just have to remember is if we can work out the rise and divide it by how far across we go, whether that's the run, then that's what the gradient is going to be. But what's important is that we can find points that we actually read the coordinate. We can't just do it any old place. Alright? So if we have a look, alright, so we, like we did last time, we plotted the points. So you have one like this. Now this is nice because I've got a point there, a point there, a point there, and a point there. So what we're looking for is the run from one point to the next and
Down.
the rise. So if we do rise over run here, it's what?
It's
So
2
the
over
rise is
1.
2, yeah. The run is
1.
1. So we have to check. So that means that the gradient is
2.
2. Okay. And remember we said before
Wait,
that
why
that
is it
number...
2? 2 divided by 1 is 2.
Now I just want to show you one other thing here. If I were to go... Do you think it would change the gradient if I went from different points?
No.
Good. So if I start here, for instance, and I go all the way across to here, okay, so I've got a much bigger triangle. What is the rise?
8.
8.
Because
so
9
one-
minus 1 is 8.
Good, yeah, so the rise in this case is 8. The run
The
is
run, so
4. So 8 divided by 4 is
2.
2. So even if I go from 2 different points, I still get the same gradient.
Mr. Potts, in year 8, we
Yeah.
didn't divide them, we just said the gradient was how many steps you go up. So in
Yeah.
year 9 is the gradient the answer
Well,
from the division?
what we did in year 8, it was always the answer from the division, but we kept it a little bit simple in that if you only go across one square,
Yeah, then
you're only
obviously,
dividing by 1.
yeah,
So then
there's a
it's
gradient.
however far it goes up.
Oh, okay.
But that's not always possible. And
Okay.
maybe we'll see a few of those.
So
Okay.
so the gradient will always be the answer of the division?
Exactly. And now if it's divided by 1, that's fine.
Okay.
If it's not, it doesn't matter, we can still do it. So the gradient is that. Okay. Right? And showing you again, it's the number there. Alright? Let's have a look. We've got to do these ones. Alright? So we've got to find the grade. Now, again, they're examples, so I'm going to do it with you, and then I'll print this out, and then you can do the ones yourself. So, we haven't got an axis, so what we're going to do for this one, because there is no axis, we're just going to count the squares. So, pick points, there's lots of points here, I can pick any that I like. So, pick a point there, pick a point here. If I do those two, I've got a
4 divided by 4,
yeah.
which is 1.
So the gradient here. So
1.
m, the gradient. Do you know why I've put m for gradient?
Yes. Wait, we meant the.
Why is it m? Because every straight line is a form of y equals mx plus c. And what I'm trying to find is the m, so I'm going to call it m. So in this case, m is 1.
Yeah.
Pick this point, and Jana, tell me when to stop. Okay, so I do, the rise is how far? 4. The run is 2, so the gradient is 2. So 4 over 2, which equals 2. Millie, I'm going to ask you for 2 points. Tell me when to stop for the first point.
Stop.
Tell me when to stop for the second point.
Stop.
The rise is
1.
the run is
2.
so m is 1 over 2. So what do we do then? Actually nothing. That's it. It's 1 over 2. The gradient is a half, or 0.5 if you like. If I'd have gone further, look, up here, it would have been, so we'll just change the colour, it would have been from here, it would have gone across 2, 4, 6, and up 3, which would have been
A half again.
3 over 6, which is
Oh, all
a
of
half.
them equal to.
It will always be a half, yeah. Okay? But because you only went across the smallest step, it went straight to the easiest one.
Yeah.
If we'd have gone further, we'd have simplified.
Yeah, because it's already simplified because she took the smallest step.
Exactly. And then finally, slight difference. Always start left to right. So I'm going to start at this point. Sophie, tell me when to stop.
Stop.
Okay. Now, the
3.
run is always this way.
1, 3.
But then we go. What can you say about the rise, though?
It's bigger than the run.
It's bigger than the run. But what is different about this one compared to the other 3?
And the line goes the other direction.
Okay, so it's not a rise. It's actually a
Run 1.
no. The run is always like that way, left to right.
But
Instead
it's
of
a rise
rising,
down.
it's actually
The
dropping, falling. So what we say is still a rise, but the rise is
3.
-3 because it goes down.
Oh, okay.
Yeah, and this case then m is
-3.
-3 over 1 or just
But
-3.
can you just do it the other way around? Like you started from the point and then you went up to the other point.
Well, if you do it the other way round, you'll end up with the wrong answer. Now, there's 2 ways to do it. You can do what we've done. We always start left and go right. Okay, so we always go that way along the arrow. So when we go on our run is always left to right. So running is always that way. Okay, but if we then, just give myself a bit of space, if we then rise, we have a positive m, but if we drop, we have a negative m. Make sense? If we were to do it the other way round, we're running in the wrong direction. Alright? Makes sense? The other way to do it is to say, well, if it's going down, it's a negative gradient. But we have to get it right that it is negative. So that's important. This one is a negative gradient. Alright? So we've got 1, 2, half, -3. So we've got that. Okay? Easy enough? Right, I'll print that out so you can stick that in your books instead. It'll be nice and colourful. Is there any extra notes you want to make on there? Because obviously these are your notes. You want anything written on there that maybe isn't there at the moment?
Wait, when you scroll down one more page, when you said about the oh no, wait a minute, what M meant?
M here.
Yeah, what M meant? Yeah.
Here. So if I write, here, look. Oh, use a different colour, be better. So if I say, because every straight line is y equals mx plus c. So just to remind you, mx means m times x. Okay, so it's multiplying. So for example, it's y equals 2x plus 4, for instance. So that means that m will be this number, and different colour. C, which we've not looked at yet, but, well, we have another, will be the plus 4. Okay, so we then know that this number, 2, the m, so m is found by doing the gradient.
Okay, so M is the gradient.
Which is rise over run.
Oh,
Okay.
that helps, okay.
Make sense?
Mm-hmm.
Right. So what we're doing is we're going halfway on to being able to actually find the equation from the line by working out gradient first. So you can see that it's 2x up here, 2x plus 3 in this place, and the gradient is 2. Alright? Highlight that. So we've got 2 and 2. Actually, I did that the wrong colour, so that would confuse you. I should do it the right colour. Which one's that one? So 2 and 2. Like that. Alright? Okay, I'll print that out.
Oh,
No.
What happened? The intercept.
Okay, well, let's have a look. So we've got this question. So what we're looking to do is now, each one of these has a function, and we now know that it's every single one of them is mx plus c, right? So m is the gradient. So if we can find the gradient, then we can then start the function. So let's just start with the gradient bit first. So this one, we're going to write, it's y equals something x. So what is the gradient of this one? Millie?
2.
2, because we go across and up. So we start with 2x plus or minus something. I'm going to come back to it. This one, Sophie, is y equals
1x.
1x, because it's find a point anywhere you like, it's 1 and 1. So we've got 1x. I'm just going to write x, alright? Not 1x, because we don't write them. Go on, and Sophie, this one will be
2x.
y equals
2x.
No.
What?
See, that's the thing. When we add another thing, we've got to remember what we've learnt before. So,
oh, 1.
Yeah, it's 1 over 2x. Yeah, remember, rise over run is 1 over 2. We stick with that. Alright? This one is y equals
Minus 1. Negative 1.
Well done. Minus x. For that.
Oh, minus 1.
Okay. Now, the next bit. If I take us back over here, right? This one here that we've looked at was 2x plus 3. Right? So if I just focus in on that. So we've got the 2, but where does the plus 3 coming? Millie's straining, so go on, Millie, go for it.
It's where they put the line of plus bit. It's where it meets, where it hits the y-axis.
So it's called the y-intercept, because if we go down the y-intercept, it's where it hits that point. Okay? So that's how we can use that. So if we then go back to this one, we go back to A, for instance, the y-intercept, the y-intercept up here, we go down the y-intercept and we find that it crosses at 0. So actually, do we write plus 0?
No, 2x.
No, we just leave it as y equals 2x. Okay. So same with the others. We have the y-intercept with this one is
minus 4.
Minus 4. Okay. So
Well,
we've got x minus 4. Yeah,
sorry,
question?
Mr. Potts, for the first one, is it still okay if we write plus 0? Or
If you do, at the moment, it's not wrong.
Right?
Well, what we do is we eventually don't do it because plusing 0 doesn't change it, so there's no point having it.
Okay.
At the moment, if you write plus 0, it's fine.
Okay.
Nothing's wrong, but you need to get into the habit of, it's like, why don't I write the 1 times x?
Yeah.
It's because it's not necessary. 1 times x is just x.
Yeah.
So at the moment, if I write 1x, fine, but we need to get into the habit of not writing it, and the same with plus 0. Let's get into the habit of not writing it eventually. If you do it at the moment, not too much fun. So, nice and easy then. I'll let you, well, alright, go on then.
Negative 4.
So,
minus 4.
C,
Yeah.
so we did B, yeah, it was minus 4. What about C?
Minus 4.
No.
Oh, 2.
Because we go Y, remember we go down, as soon as it hits, it's 2, so it's actually
2.
plus 2. Okay. This one, so y-axis, Jana, will go down, so again it's plus 2. Now I just want to one thing here I want to make you aware of. This one, look, minus x plus 2. That is fine, that's absolutely fine, and it's the right thing to do, but there is another way that it could be written that is slightly less messy, and you will see it written like this. You will see it written as y equals 2 minus x.
Oh, I get it.
Do you understand why?
But why change it around? Because now we're so used to the first number.
Yeah, you're right. You're right. We are used to seeing that as the gradient. This is the intercept. So that's...
Like, I have no problem, but it just...
Yeah,
why?
but because the reason is because now this one I've only got 1 sign. This one I've got 2 signs. So it's just a bit messy. It just makes it look neater and nicer. So you will see people will write it like this. So you have to be aware that this can be written that way round, that then you recognise as gradient. What I don't want you to say is that 2 is the gradient now. Okay. Okay, so we've got E and F to do.
But you didn't write the answer for the gradient for D.
You did? Minus
Y
1.
equals...
Minus 1, isn't it? So we go down. So it's across. So across 2, down 2.
Well, why
So
didn't
2
you write
minus
1?
2. So it's...
Why
didn't
you
I...
write 1?
We've said the same thing. Do I need to write minus 1 times x, or can I just write minus x?
Wait, so...
Because 1 times x or minus 1 times x just leaves it as x.
So if it was minus 1 over 2, it would be just minus 2.
Yeah. So in this case though, it's rise over run or drop over run, Millie. So it's not 2 over minus 2. Remember that. This is the rise.
It's minus 2.
This is the run. So it will be minus 2 over 2, which makes minus 1.
Okay.
If we go to the next one.
For E? Yeah.
So for E, so we've got y equals, Sophie?
4x minus
4.
3.
So yeah, I'm going to pick a point here, go across, up, rise over run is 4x. So I've got 4x, and then
minus
on the
3.
y down is at minus 3. You're right. I can stop doing these things now. Millie, what do you reckon it is?
Minus 2. Minus 3.
What's the gradient?
It's
So if we pick a point,
goes in 3.
pick another point,
It goes
the run
to,
is 3.
3 over 1.
The run is
Minus
minus 1, so the gradient is
3.
minus 1
over
3,
which is minus 3.
which is minus 1 over 3. It's not minus 3,
Oh.
it's minus a third.
And then minus
Then
negative
it's minus a third x
minus 2.
minus 2. Okay? Easy then, no? Good.
So you always